Hello friends, welcome back to our channel. So today we'll see one more concept in compiler design, that too in bottom-up parsing, that is LR parser. LR parser. So this is a category of bottom-up parsing. So in our previous session we have seen one category of bottom-up parsing, that is operator precedence parser. Now we are seeing the LR parser. So we know that what is a bottom-up parsing. So it will start from the leaf node and it will start parsing and it will generate the tree up to the root node. And now this LR means, L means the input will be parsed from left to right. From left to right. And this R stands for, it will use the rightmost derivation. Rightmost derivation. Right? And also here we'll be having LR of K, where K is a look ahead. Look ahead, right? So how many symbols will be parsed at a time, right? So usually this LR parser is categorized in different ways. One is LR of 0, SLR, LALR, CLR. Okay, so LR parser, SLR stands for simple LR parser, and LALR stands for look ahead LR parser, and CLR stands for canonical LR parser. Now we'll start with the LR parser, a normal LR parser, LR of 0. Okay. Now what are the steps required to construct the tree? So here also we'll be considering some context tree grammar, and then we have to take some input string and we have to verify whether the input string has been parsed with the help of the given context tree grammar. So step 1, consider the context free grammar and apply the or convert the context free grammar to the augmented grammar. So convert context free grammar to augmented grammar. So how this will be happen, I'll let you know later, right? So when we are going with each step, I'll tell you how to convert the normal CFG to this augmented grammar. And the step 2, in order to parse the input string, place a dot at the beginning of right hand side of the production. So insert dot at right hand side of all productions. For every production we have to write down, we have to use this dot symbol. Okay, this is the dot symbol. And the step 3, find out the canonical list options or list items. Canonical list items. So that also I'll tell you. So find canonical list items for all the productions. For every production we have to find out the canonical list items. Step 4, we have to give the numbering for each and every production. Okay, so give numbering for all productions. All productions. See, if it is a top-down parsing, first we have to find out whether the given productions are having the left recursion or left factoring, and then we have to avoid, then only we have to use the top-down parser. But here we need not check everything. So consider the context free grammar and apply all these things. So give numbering for all the productions. Okay, normal context free grammar. Step 5, after giving the numbering for all the productions, now generate the parsing table. Okay, generate the parsing table. Generate parsing table with the help of canonical items and numbering of productions. So with the help of the step 4 and 3, we have to create or we have to generate the parsing table. So once the parsing table has been generated, now start parsing the input with the help of parsing table. So step 6. Parse the input string using parsing table. Okay, we have to start parsing the input string. And the next one, step 7. So after completion of parsing, now generate the parse string using bottom-up approach. Generate parse string using bottom-up approach, because this is a bottom-up parser. Okay, bottom-up parser. So these are the steps we have to follow for generating the parse string. Okay, so first step, convert the CFG to augmented grammar, and second step, insert dot for all the productions on the right hand side. Step 3, find the canonical list items. Step 4, give the numbering for all the productions. Step 5, by using this canonical list items and the numbering of all productions, generate the parsing table. And step 6, with the help of parsing table, parse the input string. Consider one input string and you can parse the input string. And step 7, finally we have to generate a parse string. So these are the steps. Now we will go with a one by one. So step 1 to step 7. Now let us take an example and we will see how the parse tree can be generated by using this LR parser. See, I am taking an example here. S tends to A, A tends to A, and A tends to B. So this is an example. For this we have to construct the parse tree using LR parser. Okay, LR parser. So LR is this one also, right? Yes. So this is the given context-free grammar. Now we have to convert into augmented grammar. So conversion of augmented grammar means take a one more production which gives and which tends to the starting symbol. So here the starting symbol is yes. So take one more production, S dash tends to S, and S tends to A, and A tends to A, and A tends to B. So this is the augmented grammar. So in order to stop or accept condition, we have to use a one more production, the extra production, which maps to the starting symbol. Now the third step is, so this is the augmented. Okay, this is the augmented. And the next step is we have to insert dot symbol at the starting of every right hand side of the production. Every production right hand side. So the next one, S dash tends to dot S. S tends to dot A. A tends to dot A. So here small a is a terminal, capital A is a non-terminal, and again A tends to dot B. So this is the first step, second step, right? And now we have to find out the canonical items, canonical list items. So we have to expand by start parsing this dot from rightmost to the leftmost. Okay, now canonical list items. Okay, canonical list items. Now you can draw the flow chart. Okay, it will be very good. So flow, not a flow chart, it's a data flow diagram. Okay, so you can draw the data flow diagram, or simply you can write down the steps. So this is a simple production, so I'll do the data flow diagram. I'll go with the data flow diagram. First take down all the things, okay, all the productions with parsing, about to start parsing is a dot, with a dot. So I'll go with this one, s dot, s tends to dot s, and s tends to dot a tends to dot a, small a, capital A, and a tends to dot b. So this is a start symbol. So let us consider it as a I0. I0 means nothing but a states. Consider them as a states. I0 means zeroth state. Now we have to find out for all the things. So you can see there are different possibilities from up to S, up to A, up to small a, up to small b. So you can go with you can expand this with the next level. So upon S dash upon S, so it will be S dash tends to move the dot symbol towards a one position. S dot. Okay, S dot. And now you can observe for this production, the dot will not be produced further. That means it came to the end of the production. See, for example, consider it as AA. This implies the parsing is going to be start from here. In the next step, it will go here. In the next step, it will be moving towards next one. So there is no other symbols, terminals or non-terminals to parse. So that implies that production has been parsed completely. Okay, so the same thing happens here. The same thing happens here. So simply you can say this will be the leaf node, because we cannot expand. So when it can be expanded means if there is any possibility to parse the further symbols. See, for example, this can be expanded further. This cannot be expanded further. This can be expanded, right? Because this dot represent parsing. Imagine dot represents a parsing. So for every step we are parsing each and every symbol and moving towards the right hand side, end of the production. Now next, if it is with A, S tends to A dot A. So whenever you got in this similar way, so for example I'll write here, S tends to A dot A. So whenever you got this dot A, write down all the productions of A here. Okay, in this level. Now you got A dot A. So A dot A means whatever the productions we are having, we have to write down these in this particular level. So dot A. So dot A means A dot small a, capital A tends to dot B. So this is a one more. And coming to the next one, if with a small a, so small a, you can see A tends to A dot A. Again we got same thing, dot A. So dot A means again we have to write all the productions of A. So write down all the productions of A. A tends to dot A, small a tends to dot B. Okay, and then with a B, simply we will get A tends to B dot. And here you can see this production we can't expand further. Now give the state numbers here. Okay, I0. Now this becomes I1, and this becomes I2, and this becomes I3, and this becomes I4. Okay, I4. Now expand this one. expand this one. So this cannot be expanded, right? This cannot be expanded. So this can be expanded. So again you can see there will be three options. One is with A, B, A, capital A, small a and small b. Now with a capital A, what happens with a capital A? S tends to A dot. A dot. So here it ends. Here it ends, right? Because the dot, the parsing has been sent to the last position, so it can't be further expanded. Now with A, what happens? A tends to A dot A. If it is A dot A, what happens? We have to take one more production, A dot A, and A tends to dot B, right? So you can see the same state repeating. Here we have given some I3. The same state has been repeated here. Okay, see, A tends to A dot A tends to dot A tends to dot B. The same production. So you need not further expand this one. Okay, so simply upon A, it will moving on with I3. It will be moving on I3. Right? Now, once again, there is a one more chance. It is B, that is A to B dot. So you can observe A tends to B dot. These are already generated with a state 4. So you can replace this with a state 4. State 4. Okay. Repeat the same process for this one, I3 also. So with A, it will be A tends to A dot. So it cannot be further because dot has been reached to the end of the production. And with also A, it will be A tends to see, it will be going with A dot A, and here again it's a dot A. We have to write on A, and A tends to dot B. So again you can see the same thing. Okay. So, here it is a capital A. So capital A, parsing on capital A, parsing on small b, parsing on small b. And here parsing on capital A, parsing on small a, parsing on small b. Okay, after dot, whatever the symbol we are taking, that we have to do. So the same thing repeated, and again I will go with the same loop, that means same state I3. And again here on B, it will be A tends to B dot, which is nothing but I4. So again it will be I4. So go with the next level. So give the states and go with the next level. So I am giving the states. I0 given I1, I2, I3, I4, and this will be I5, and this will be I6. So no other production can be further expanded. So we have to stop here. So this is the canonical list items. With all the states from I0 to I6. If this I5 is further generated, that should be again expanded. Okay, so this should happen until there is no expansion of any one of the production, and all these productions should be parsed. You can see in I4 the third one has been expanded. The third one has been completed, parsed completely. And coming to the I5, the first production has been parsed successfully because started with right hand side dot on the right hand side production, and now the dot becomes the last one, and I6 is the second production, right? Now we have completed. Now we have to generate the parsing table. I will generate the parsing table. So there will be two options. One is a action option, another one is a go to option. The first one is action option, another one is a go to option. So on the action option we have to give all the terminals. On the go to option we have to give all the non-terminals. So here on the action, what are the terminals we are having? So A, B and take the dollar, because the input string, end of the input string we are giving some dollar. And coming to the go to, we are having two non-terminals, S and A. Yes, A. Okay, this is a row. Now what about the, sorry, these are the columns. Now what about the rows? The number of states are represented as a rows. So we can go with the rows. See, I'll write here because yes, I'll write here. So rows are states: I0, I1, I2, I3, I4, I5 and I6. And actions are terminals. So A, B, dollar, and the terminals are yes, A. So these are the actions, and this is the go to. And now you can create the parsing table. You can create a parsing table with the help of canonical productions and the numbering of productions. So this is the okay. So I am creating the complete grids. I am drawing the grids because there will be no confusion about this. Okay. So there is a completely zigzag position, so don't worry about that. I just, and give the productions, give the numbering for productions, and this will be given as 1, 2 and 3. So don't go with the augmented grammar. So go with the original grammar and give the numbering for the productions. Now let us start. In the actions, we have to write it as a shift. Okay. In the go to, we should write it as a reduce. Okay. Now start. I0. So here I0 on A. I0 on A goes to the I3. I0 on A goes to the A. Sorry. Yeah. I3. I3 means give it as a shift 3, represent as S3. And I0 on B. On B it is I4. So we have to specify it as S4. Now I0 on S goes to I1. I0 on S goes to S1. So here give only the numbers. Okay, don't go with the shift or anything. So give the numbers. And see, I0 on A go to the I2. So I'll give the number 2. Now coming to I1. So I1 was not able to process next. I mean further. So S dot means the start symbol has been parsed. So I1 on dollar will be accept stage. I1 on dollar will be the accept stage. And I2 on A go to 5. I2 on A it goes to 5. I2 on small a goes to I3. I2 on small a goes to I3. That means S3. If it is actions, give the shift. I2 on B goes to I4. So S4. Next, I3 on capital A goes to 6. I3 on capital A goes to 6. I3 on small a goes to 3. Again S3. I3 on small b goes to 4. S4. Okay. Now coming to I4. So I4 is last. Okay. So the production ends here. And is this just a start symbol? No. So what is this production number here? B dot. So that is a third production. So go with the reduce for I4. So it will be R reduce, third one 3, and give the same for everything, R3. Coming to I5, again this is the last, right? So which production has been ended, and is the start symbol? No. So this is one production. What is the production here? Number 1. So I5 will be reduce 1. Reduce 1. Next I6. This is also last one. And check whether it is a start symbol. No, this is not a start symbol. Then what's the production number? A dot 2. Go with the R2. R2. Okay, so this is the parsing table. So we have generated parsing table from this canonical list items. Don't get confused. Fill the parsing table with a careful manner. Okay, so for all the possibilities, fill the actions. So if it points towards any other productions, go with the shift, and if it points, it moves with the terminal, then only we have to go with the yes. If it moves on the non-terminal, give the numbering, just a number. Now the next step is we have to take one string and we have to parse that particular string. Now let us, I'll erase this one. Okay, I'll erase because hope you have noted this down. So I'll erase. And the next step is we have to parse this input string. We have to take the input string. So I'll take the input string as A, B, B. A and B, B. Now consider the string. So here let us consider it as a stack and input string and the action. See, this is also very important. So initially the stack will be empty and dollar will be pushed. Input string will be A, B, B, dollar. So we know that input string should be appended with a dollar because that gives end of the string. Now initially start with the initial symbol, start symbol. So where the start symbol is appeared, that will be in the starting state, that is 0. So from 0 we have to start. Okay, we have to start from 0th state. That's the start symbol. So that's why I have kept here 0. Now see 0 on A, I0 on A, it's a 3. So what's the action we have to do? Shift input to stack, okay, and place 3 because it is a S3. So what we have to do in our next case, what we have to do, $0, push this input symbol A, and what is the value here? 3. So I have to keep here 3. Okay, once again repeating. So 0 on A in the parsing table, 0th state on A, it gives a shift 3. So shift the input first towards the stack. So A will be shifted towards stack and place 3 because it is a third state, right? Shift 3. So 3 will be placed here itself. So always I will write here shift with S3. I will write in this way. Okay. So in order to avoid the place, I will write in this way. So now the input will be A, B, B, dollar. Now again you can check with 3 and A. State 3 with A, shift 3. Again the same thing will be done. So shift with S3. So what we have to do? First we have to push A into stack. So $0, A, 3, again A, and again the symbol is 3. So again we have to give us 3 here, and it will be B, B, dollar. Okay, hope you understood. So again shift with S3. So A will be pushed into the stack and 3. So 3 will be placed here. Again now we have to go with the 3 with B. 3 with B. So 3 with B, it's a shift 4. Now again shift with S4. What we have to do? The next one will 0, A, 3, A3, B4. Okay. Now the remaining input will be B dollar. B dollar. Now again go with the 4 and B. 4 with the B. See, 4 with B. Now it is a reduce 3. So reduce 3. So what is the 3 here? A tends to B. Okay. Here 3 means a production. A tends to B. Now we have to replace this B4 with this 3, production 3. Okay, production 3. That means a reduce. That means we are reducing the stack to the productions. We are applying the productions to the stack value. So the next value will be 0, A3, A3. For B4 we are taking it as A, capital A. Capital A. So what about the number here? So there is no number. Now use 3 and A. 3 and A. Okay. So here B4 has been reduced with production 3 capital A. Okay. B4 reduced with third production capital A. Now there is no number here because here you can see we are comparing or we are getting the shift or reduce values with the help of state number and the terminals and non-terminals. And here we are not having any state number. So we have to check with 3 and A, reverse process. So 3 and A, it is 6. So give here 6. Give here 6. Now it will be B dollar. So check with 6B. State 6 with B R2. Now again we have to go with the reduce 2. Reduce 2. So this is nothing but A tends to B, and this is nothing but A tends to A small a capital A. Now you can observe here, so forget about the states, it is small a capital A. So everything can be replaced with this particular A. So what happens here? 0, A, 3, capital A. So this complete replaced with A. Now again there is no number. What we have to do? Again we have to check with 3A. So 3 with A, it is 6. Again we have to go with 6. And now B dollar. Check with the B and 6 and B. 6 and B. Reduce. 6 and B is reduce. Again we can reduce. Okay. So reduce 2. So again A tends to AA. So again what we have to do? Again we have to perform 0. What happens here? A3, A6. So A, 0A, and here it is B dollar. Right? Now again there is no number. So again A0. A0 or 0A, it is 2. We have to check with 2 and B. 2 and B. 2 and B is 4. Shift with S4. What we have to do? Again we have to place 0, A, 2, B and 4. B and 4. It's a dollar. It's a dollar. Now you can check with this one. So 4 and dollar. 4 and dollar. It's a R3. Okay, R3. So reduce 3. So what is the third production? A tends to B. Now what happens here? This can be replaced with dollar 0 A 2 A. 0 to A. Okay. So again 2A. So 2A. 2A. It's a 5. It's a 5. And it's a dollar. Okay, $5. So 5 and dollar compare. So 5 with a dollar, 1. You can go with a reduce 1. What's the 1 here? S tends to AA. Now what happens here? We have to replace it with dollar. AA can be replaced with 0 S. 0 S. Okay, you can see 0 S is 1 and this is a dollar. And now you compare with 1 and dollar. 1 with a dollar, it's an accept. 1 with a dollar is an accept. So like this we have to perform the shift and reduce operations with the help of this numbering of productions as well as this parsing table. So actually the parsing table has been generated with the help of this numbering productions and the canonical items. So with the help of this parsing table itself we can reduce. We can use a shift and reduce. Okay, so one thing we have to remember, so every time we have to compare the state with the stack of top of the stack. Okay, so hope you understood this one. Hope you understood. Now the last step. So this is the parsing of input string. Now the last step is a parse tree. So what's a parse tree? From bottom we have to go. So what's the bottom? Yes. Yes. Then S can be expanded with A. So A. And this A is expanded with B. And this A is expanded with A and A. Again, this A is expanded with A and A. See this one. And this A is expanded with the B. Completed. Now you can check A, B and B. So you can write out all the leaf nodes, that is A, B. That's the input string. Okay, so we are going from bottom to top. So previously we have started finding the expansion of or generating the parse tree from top to bottom. Now in this case we are using the bottom up approach. Okay, bottom up approach. From the bottom level we are going towards the top level. So by using that we have generated the parse tree. That implies the given input string A, B can be parsed with the help of this particular context free grammar. Okay, so this is how we can generate the parse tree using LR parser. Okay, so this is the first category of LR parser, LR0 parser. So first step we have to create the augmented assignment, and the next one we have to insert the dot symbol on all the productions of the right hand side of all the productions, and then we have to find out the canonical list items, and with the help of canonical list items, and the next step is give the numbering for the productions, and with the help of these two, that means numbering of productions and the canonical items, generate the parsing table, and use the shift and reduce here, and by using the parsing table parse the input string using shift and reduce operations. So shift operation means shifting the input string towards the stack. Reduce means reducing the stack values with the non-terminals. And after that, so generate the parse tree using the bottom up approach. So be very careful while doing this one. So if you do anything small wrong, so automatically the complete procedure will be get wrong. Right? So let's stop here. Hope you understood and enjoyed the session. If you are having any query or if you felt any difficult in this process, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. And if you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.